So our last couple of classes, we were doing arithmetic sequences, geometric sequences, arithmetic series, geometric series, and we kind of had all those in our notes. And so I thought it would be good for us to do a class kick together in a concise way so that you have all of the formulas in one spot. So this first slide that we're doing here, I'm just going to give you the formulas. I would highly suggest you write these down because when we do an assessment, it would be great to have these all in one spot. So remember the sequences and series were strings of numbers. An arithmetic sequence, the formula for an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d. So that is our first formula. You guys probably should be writing that down in your class kick there, okay? For a geometric sequence, the formula is a sub n equals a sub 1 times r to the n minus 1. And I'll go back over what all the variables mean, but just quickly, remember D is the common difference for a sequence, and R is the common ratio, how much they're going up each time, whether it's addition or multiplication. All right, the next formula is for an arithmetic series. That was S sub n, so S is for sum, so S sub n is equal to n times a sub 1 plus a sub n, all divided by 2. And then the last one for a geometric series, that formula is S sub n is equal to a sub 1 minus a sub 1 times r to the n, all divided by 1 minus r. Yeah, the question was, what does S sub n mean? S sub n, S stands for sum, and so that means this when you add all the numbers together. So S sub n means the sum of all the numbers. So the first thing you want to do is you figure out, okay, is it arithmetic or is it geometric? And then once you have that figured out, okay, am I just finding a number, which is a sequence, or am I finding a sum, which is the series? So let's go to the second slide here, and we're going to use this first slide as a reference. So the first question says, the first 3 terms of the sequence, so that tells me right there, it's a sequence, not a series. The first 3 terms of the sequence are given, and we're trying to find the 36th term. So the first thing I want to do is determine, is it arithmetic or geometric? So looking at these, let's see, from 403 to 395, well, that would be subtracting 8. So now I want to see if I subtract 8 again, so 395 minus 8, does that work? And yes, it does. And when you're adding or subtracting something, that means it is arithmetic. So now I've determined it's arithmetic and it's a sequence. So I'm going to go back to the first slide. And I'm talking about an arithmetic sequence. I'm going to use this formula. So you just want to determine which formula you're using for, is it arithmetic or geometric, and a sequence or series. So now to find the 36th term, that means I'm going to find a sub 36, that means the 36th term, is equal to a sub 1, the first term, which was 403, plus n minus 1, Well, n is the number, so that's 36 minus 1 times our d value, which was -8. And now we're just going to plug that in. So I determine what formula to use. Now I'm just going to plug it into my calculator. So I have 403 plus 35 times -8. Out there. I've got 403 plus 35 times -8. My answer is 122. Okay, again, what that means is if I did -8, -8, -8, -8, I kept doing that, the 36th number in that sequence would be 123. Okay. Let me do one more, and then I'm going to have you guys do it. So for the next one, problem number 2, we want to find the 9th term in this sequence. So I know it's a sequence. Question is it arithmetic or geometric? Well, I'll first test to see if it's arithmetic. That would be plus 12, like 6 plus 12 is 18. But if I did plus 12 again, that doesn't work. It doesn't give me 54. So that means it's not arithmetic. So now let's see if it is geometric. Well, I know that 16 times 3 is 18. And let's see, is 18 times 3 54? It is. And of course, I could always check that using my calculator. But because we're multiplying now, that tells me it is geometric. So I know it's geometric and it's a sequence. So I'll go back to the first slide here, and I'm now using this formula. Okay. So for a geometric sequence, define a sub 9, meaning the 9th term. I do a sub 1, which is 6, times r, which is 3, to the n minus 1, which is 9 minus 1. So I'm doing 6 times 3 to the 8th. So 6 times 3 . Sorry, I messed my thing up. It wouldn't have mattered either way. 6 times, I'm really messing up here. 6 times 3 to the 8th. There we go. And that's a pretty big number. Okay, so that grows real quickly. So I have 39,366. Okay, so again, what that means is, I mean, this is our answer, of course, but if I were to, multiply by 3, multiply by 3, multiply by 3, and I did that, the 9th term in that string would be 39,366. Okay, so I would like you guys to just try problem number 3. Okay, do number 3, please. All right, so if we're going to do number 3, first thing we want to do is figure out, is it arithmetic or geometric? What do you think? Yeah, good. It's geometric, right? Because, well, let's see. You might not know off 8 or 16 times what is 80. Well, an easy way to figure that out is, let's just do 80 divided by 16. And it's 5, right? So I'm thinking geometric. I'm thinking this is times 5. But if that's the case, then I have to make sure that 80 times 5 is 400. Well, it is, of course, because 8 times 5 is 40. You add the zero. So I now know it's geometric. It's a sequence because I'm just finding a term. So I'm going to use my geometric sequence formula. So I'll do a geometric sequence formula is that I'm finding a sub 6, meaning the sixth term. That's going to be a sub 1, which is 16, times our r value, which is 5, to the n minus 1, which is 6 minus 1. So on my calculator, I'm going to do 16 times 5 to the 5th. So 16 times 5 to the 5th, I get 50,000. All right, any questions on those? We okay so far? All right, let's go to the next slide then. So in the next slide, this thing right here, that little symbol, that sigma, that means you're going to add things together. So that's a dead giveaway that this is now a series. And so we now know that it's a series. So I'm going to use one of these two formulas. I don't know which one yet, though. So let me go back to it and say, okay, I first need to figure out what the heck all that stuff means. I know this part means we're going to add them up. This number is the first number I'll plug in for n. So if I did 6 times 0 plus 3, I get 3. And then I'm going to plug in a 1. 6 times 1 plus 3 is 9. Then I plug in 2. Whoops, 6 times 2 is 12 plus 3 is 15. Sorry. And then I would plug in 3 and then 4 and then 5 and then 6. But I'm not going to do all that. Okay. I'm just doing a couple to see if it's arithmetic or geometric. And looking at this right now, I can already see that it is arithmetic because I am adding 6 and adding 6 and so on. So my D value is 6. So I'm going to use my arithmetic series formula, which is this guy. So I'll actually just rewrite that. So to find S sub n, I'm going to do n times a sub 1 plus a sub n all over 2. Well, n is how many terms there are. So to find the total number of terms, if I plug in 0, then 1, then 2, then 3, then 4, all the way up to 82, there's actually going to be 83 terms. Okay, because like 1 through 82 would be 82 plus the 0. So I have 83 terms. My first term was 3. Okay, and that was here. My last term, though, I didn't figure out my last term. Here's how we find a sub n, meaning the last term. Well, I'm going to add all those up, and then I'm finally going to plug 82 in for n. So I'm going to do 6 times 82 plus 3. So 6 times 82 plus 3 is 495. That's going to be my last term. Okay, I'll write it up here. You guys wouldn't have to, but we definitely have to write it here, 495, all divided by 2. So now this is what I'm going to plug into my calculator. So I have 83 times, well, 498. I could just add those, right? So 83 times 498 divided by 2. and I get 20,667. All right, so in doing that, you guys don't necessarily have to write this part. I just did that so you can kind of visualize what's happening. That 20,667 is how much all of these things add up to. Okay, but the key is I do need the first term and I do need the last term. I get the first term by plugging in the first number. I get the last term by plugging in the last number. All right, so I'm going to have you guys try problem number 6, and then we'll go over that in a minute. All right, guys, let's go over this problem number 6. So I'll plug a 1 in here. 5 times 1 plus 4 is 9. 5 times 2 plus 4 is 14. 5 plus 3 plus 4 is 19, and so on. So I could see that it is arithmetic, and my D value is equal to 5. So to find my sum, it's going to be N, which in this case is 93, because remember, I'm starting at 1 and going to 93. So to find this, to find the N value, you can always do the top minus the bottom plus 1. So like here, if I did 82 minus 0 plus 1, it'd be 83. 93 minus 1 plus 1 would be 93, of course. So I have 93 times our first term, which was 9, plus our last term, which I didn't find yet because I needed to find that by plugging a 93 into there. So I'll do 5 times 93 plus 4, which is 469. And then don't forget to divide by 2. So I have 93 times 9 plus 469. So that's going to be 478, right? So I could do 93 times 478 divided by 2. Okay, so I get 22,227. Okay. All right, let's go to the next page then. And then for this next page, we're going to try and find the sum of the first 6 terms. Well, first, because it says sum, I know it's a series. And I have to first figure out, is it arithmetic or geometric? Well, I'm looking at this, and I do know that 9 times 6 is 54, meaning like 54 divided by 6 or times 1/6 is 9. But I don't know if that is 1/6 also. So I'm going to check. I'm going to do 324 divided by 6. And with any luck, it's 54, meaning this is geometric, and our R value is 1/6. So I now know that it is a series because it's a sum, and it's geometric. So I'm using, from the first page again, the geometric series formula. So I'll just rewrite that here so I don't have to flip back and forth. S sub n is equal to a sub 1 minus a sub 1 r to the n over 1 minus r. The equation is the geometric series. All right, so let's do our a sub 1 is our first term. So that's 324 minus 324 times 1/6 to the 6th power. And I'll divide it by 1 minus 1/6. And that is an ugly looking number, but that's why they make calculators, right? So all I'm going to do is plug that into my calculator, and hopefully I get a nice number. So here we go, guys. So I'm going to start off by making my fraction. I have 324 minus 324 times 1/6 to the 6th power. So those calculator skills are coming in handy here. So I have 1 minus 1/6. And so I get this fraction. It might be a little bit more helpful to have than a decimal. So 388.792. Oh, wait a second. Oh, I'm sorry, because this is the sum, yes. So I got 388.792. And so again, that means if I, took that 9, I divide by 6 and get the next one, divide by 6, get the next one. But it did that and got 6 terms and added them all up, that would be my sum. All right, how about if you guys try problem number 9, please? All right, so this one is also geometric because it is times 4 and times 4, meaning our R value is equal to 4. And so using the same formula that I used above here for a geometric series, I know it's a series because I'm finding the sum. So that's going to be a sub 1, which is 14, minus a sub 1 times our R value, which was 4, to the n power, which is 7, all divided by 1 minus 4. 7 is how many terms we're adding together. So since we're adding together 7 terms, our n is equal to 7. Okay, and so now we're just gonna plug that into our calculator. So I've got in my fraction 14 minus 14 times 4 to the 7th all over 1 minus 4. You could put -3, of course. And I get 76,454. All right, any questions?